Good morning, good afternoon, everyone. This is again Miss Marte and her special guest, Miss Lavnika. Today we will be talking about solving linear systems by substitution. Yesterday we talked about solving linear system by graphing. Our struggle was that sometimes it's hard to graph certain lines, and sometimes it is even harder to figure out from a graph the point of intersection. If the point of intersection is 2.375, that's very hard to read from a graph. So we need an algebraic method, and the first algebraic method is substitution. Miss Navnika, please explain to me what this is.
Well, substitution means that you substitute something for something else. And looking at our given system, in the first step, we will have to isolate either x or y.
Which one?
Looking at the system, I would go with a first equation, and I would isolate y value. It requires the least amount of steps to do it. So if I isolate y from 1, I will take that value and I will substitute it in a second equation.
Why from 1 and not from 2?
Well, in a second equation, if I would have to isolate either y or x, at the end I would have to divide by either 2 or 3. And if I'm isolating from 1, y coefficient is 1, so all I have to do is to subtract 2x from both sides.
Okay, so you convinced me. I isolated y, and it's nothing else but 2 minus 2x. What do I do next?
Take the second equation and substitute this y value for a y value in the second equation.
Substitute y equals 2 minus 2x into the second one. Please notice that I used 1 here. I isolated from 1 and I substitute into second one. Okay, so my second equation is 3x plus 2y equals 1, but y has a new name, and the name is 2 minus 2x. A little bit of algebra here.
Using a distributive property, you will open up the bracket, so it's 4 minus 4x. Collect like terms. Will give you negative x plus 4 equals 1. Subtract 4 from each side, and you ended up with a negative x equals negative 3. Therefore, x coordinate of a point of intersection is 3.
Am I done?
No, you're not done. Any point has 2 coordinates, so the point of intersection has to have 2 coordinates. Choose one of the equations.
How about I already isolated y equals 2 minus 2x. Can I use this?
Yes, you can, and substitute for x value 3.
So
calculate your y value.
So my y value is negative 4.
That's correct.
As a result, the point of intersection as an ordered pair is 3 and negative 4. Good. Now, this is a nice algebraic way to solve a system. But whenever we solve algebraically, we like looking at the corresponding graphs. So how about we do that right now? Let's bring this to the front so we'll see it better. So here I graphed my 2 equations. Can you help me please? Which one is which?
The first equation is graphed in a blue line, as a blue line.
This is blue.
Yeah. And the second equation is graphed as a red line. So as you can see, they do intersect. The location of a point of intersection is indeed 3 and negative 4.
Okay, exactly what we got algebraically. The point of intersection is 3 and negative 4. Now,
how about we check our solution as well?
How am I going to check my solution?
Well, as we mentioned before, a point of intersection is actually two points on the top of each other. And the point of intersection, therefore, has to satisfy both equations. Substitute 3 for x, substitute -4 for y.
Okay.
And the numerical values on left and right side must equal.
Okay, so let's see if that happens indeed. So I have a 6 minus 4. Guess what? My first equation is satisfied because 2 equals 2. Now let's see if the second one is satisfied. 3x plus 2y. I want it to be equal to 1. Let's see if that happens.
So again, for x it's 3. For y value is -4. Following the BEDMAS.
And guess what happens again? 1, left side and right side are again equal. And what I really like about this check is that I do not need to check the back of the book. I know I'm right. I don't need to ask my teacher. Thank you.